Okay, from yesterday, I would like you to perform the chain rule with problem number 1 and problem number 2. See if you can practice the chain rule with problem 1 and problem 2. This is our checkpoint for the day. This is our checkpoint.
Let's get some.
Welcome, Taylor. Taylor is going to sit in the calculus classroom because she finds it inspiring. We're going to allow her to join? Suppose, you suppose. Very good.
Our secret club.
Secret club.
Wheel fam.
Everybody good?
Yep.
Okay, let's check it out. Now, I'd like to show you a little bit of a shortcut. Are you ready?
Yes.
The chain rule is really the derivative of the inside, which is 2 times the derivative of the outside, with the inside left alone.
Oh.
Watch. Suppose you have the sine of 4x. I need to use a chain rule. What's the derivative of the inside? 4 times the derivative of the outside. Cosine with the inside left alone.
I like my square.
Yeah, okay. Rose is safe for everybody to hear. What'd you say?
I like my square box.
Yes, and I noticed that a lot of people like square boxes. So, without a doubt, when I set up these problems, I will use the boxes. However, there will come a time where when we take the derivative of sine of 4x, I will not set up the boxes. I will say the derivative of that is that, okay? So we'll kind of get some of those points. This one right here, okay? We'll set up the boxes per request. We have 6u to the 5th, and we have x minus x squared. The derivative is 1 minus 2x. The derivative is 30u to the 4th. And so I have 30 times 1 minus 2x times x minus x squared to the 4th power. If you chose to distribute the 30, you get 30 minus 60x. That would be fine as well. The chain rule. You got it?
Yeah.
No big deal, huh? Nice job. All right, let's try this one. The inside is 5x squared. The outside is negative 4 secant of u. You're trying to earn your deriver's license. Who knows what the derivative of negative 4 secant of u is? Secant tangent. And the derivative of 5x squared? 10x. I multiply, I get negative, I get negative 40x secant of 5x squared, tangent of 5x squared. No big deal, right? Piece of cake upside down. How would you go about number 4? Good, good. Haley's on the right page. It says negative 5 times x plus 5 raised to the negative 7th power. Instead of using the quotient rule, she wants to use a chain rule. Good for you. And so we end up with negative 5u to the negative 7 and x plus 5. And the derivative of x plus 5 is 1. The derivative of negative 5u to the negative 7th is? Or in other words, 35 over x plus 5 raised to the 8th power. You guys feeling pretty good about the chain rule? You know what you're doing, don't you? What makes problem 5 different? That x in front, isn't it? I mean, for example, suppose it was 2x times the sine of x minus 4. What rule would you use in that scenario? The product rule. So in this situation, we have the product rule in conjunction with the chain rule, okay? And so that's what today's and tomorrow's lesson is about. Tomorrow you should get a pretty decent amount of time to work on your assignment. But today we want to look at the chain rule in conjunction with other rules. And this is where it gets a little bit trickier. So we'll see how you handle it, okay? I'm going to call this function f. I'm going to call this function g. And so I'm going to set up the product rule. I have f prime of x is equal to, what is the derivative of 2x? Times 4 minus x raised to the 4th power. Am I done?
No.
No. Plus, I now need g prime, don't I? But I'm going to write down f first, so I'm going to write down 2x, and I got to multiply that by g prime. What rule would we use to find the derivative of g? The chain rule.
Oh man. Oh man. It's okay.
The inside is 4 minus x. The outside is u to the 4th. So I have 4u cubed, and the derivative of 4 minus x is? And so I get times negative 4 times 4 minus x to the 3rd power. Need to work to simplify that. F prime of x is equal to 2 times 4 minus x raised to the 4th power minus 8x times 4 minus x to the 3rd power. When you use the product rule in conjunction with the chain rule, you must write it in factored form as the answer. That's the only way I see it expressed on the AP exam ever, and it's the only way I see it expressed in your textbook. So we're going to say that if it's good enough for them, it's good enough for us as well. So I'm going to go ahead and take out a common factor. What common factor can you take out of each of these? A 2. And what else?
The 4 minus x.
The 4 minus x cubed. Does everybody agree that each of these has a factor of 2 and each of these has a factor of 4 minus x cubed?
Mm-hmm.
So what do you get if you take out a 2 and a 4 minus x cubed out of that? Good. Good morning.
Morning.
And what if you take a 2 times 4 minus x cubed out of this? What are you left with? A 4x. So notice in this last piece here that there are then 2 terms that you can combine together. F prime of x is equal to 2 times 4 minus x cubed times 4 minus 5x. And that's the factored form. Rosa, would you like to share your thoughts?
That's okay.
All right.
I'm gonna be kind today.
So I want to look at the reality of it. The calculus was done right away. The rest of it was not calculus. It was your beloved algebra.
I hate algebra.
And most people, they say that they are one with algebra. That's what they love. But the truth is that what's going to make your mistakes on the test, most of the time it's your algebra. It's not your calculus. Okay.
I'm one with the trees.
One with the trees, yeah. All right, let's look at another one. Can I get your feet wet with this? The next one involves more than one rule. More than one rule. It says sine squared of 3x. And so this is understood to be sine of 3x, that quantity squared. I'm going to use the chain rule twice in this scenario. Okay? Sometimes it's easier to look at this and say, instead of what is the inside, sometimes it's easier to look and say, what is the outside? Anybody see what is the outside representation? U squared. So the inside is sine of 3x. If you start with the inside, most people would have written 3x right away, agreed? When we have multiple chain rule situations, easier to look at the outside structure right away. What is the derivative of u squared? 2u. Now, because Rosa likes the boxes, we're going to set up the boxes, but I'm going to show you what happens if we wouldn't set up the boxes. I need the derivative of sine of 3x. That also requires the chain rule. It's not sine times 3x, it's sine of 3x. So I'm going to now find the derivative of that using the chain rule. I have sine of u, and I have 3x. The derivative of 3x is 3, and the derivative of sine is cosine. So when I multiply these together, notice you get, and that's what goes in this box then, is my new derivative, 3 times the cosine of 3x. If we decided to not use the boxes, we say the derivative of the inside is 3 times the derivative of the outside, which is cosine with the inside left alone. So if you don't feel like setting up that second set of boxes, that's fine. When you do multiple rules, sometimes people like to navigate that way. So now we're going to multiply these together, and remember, you have to plug the sine of 3x in for u. So as you multiply these together, the 2 times the 3 becomes 6 times the sine of 3x times the cosine of 3x. And that's my derivative. What do you think? Let's skip a couple problems. You guys are super smart. Let's move to problem D. Talk to the person next to you. How do you think we approach this problem? Okay, go, talk. How do you think we approach this problem? Problem D. What do you think?
At least 2 of them.
I think we use the quotient rule, then you have to use the chain rule for each.
Quotient rule or the
Use the chain
Find the D, or the
and
product
then
rule.
use the product rule with our
Yes,
chain.
right. Yep.
You box chain product. Box head. Who's in your head? Right, box, brain.
Okay, the answer is the product rule with the chain rule twice. So we have 3 rules going on here. We have the product rule because these are being multiplied together, and then we have the chain rule twice. Okay, so let's set that up. First, I'm going to, as people said, I'm going to box that one. Is that the terminology we're using?
Box it.
Okay, so we're going to box each of these.
It used to be in the box, but now I make the box.
And I have u to the 5th and x plus 2. And I have u to the 7th and 3x minus 8. And so I have 5 u to the 4th.
Attention students, with the last name L through O, please report to the auxiliary gym. Again, students with the last name L through O, report to the auxiliary gym for pictures.
And in this box here, I have 7u to the 6th, and I have 3. So below, I will write my derivatives, which would be 5 times x plus 2 raised to the 4th power. And here I have 21 times 3x minus 8 raised to the 6th power.
Yeah. And then we gotta do this.
So if we call that F, and then we call that G, I'm going to use this space because we don't need that. You guys already know how to do that. You're really smart. Super smart. You tell me.
derivative of f,
which is
which is 20.
5 times x plus 2 to the fourth. Good.
No, it's not 20.
We already took that derivative, right?
Right.
Times what?
Oh, you go back to the original.
Good. 3x minus 8 to the 7th.
Oh, I get it now.
Then what? Plus. Now what, Arky?
X plus 2 to the 5th.
Okay.
And then times 21, 3x minus 8 to the 6th.
Yeah. Excellent. It was the product rule in conjunction with the chain rule, which means that I have to write it into factored form.
We got this.
Why do I say we have to? We get to. Like, what an awesome challenge that is. Common factor. What do I take out? X plus 2 to the 4th and 3x minus 8 to the 6th. Excellent work. So that's my common factor. To emphasize that it is a common factor, I like to use big parentheses. So, and then sometimes I go back and I kind of underline it so that I know exactly where I'm headed. I got that x plus 2 to the 4th, that's gone. And then 6 of these are gone, so what's left over? Okay. Plus, thank you, this is very important. A lot of people miss this part. Plus, good, times 21. Sweet. Yes.
In the top, where it says, or in the beginning where it says, the in parentheses, the 3x minus 8 to the 7th power.
Yeah.
Where did the 21 go?
Okay. So this was f prime, so that was the derivative of my first one, times g, so that's this function left alone.
Okay. Oh.
Plus, this is now f, the original function, times g prime, so the derivative there. So the 21 only came up when we took the derivative. We good?
Yep.
Okay, so now I want to combine some like terms there. So I have f prime of x is equal to, we're almost done, x plus 2 to the 4th times 3x minus 8 to the 6th. So we know we have that up front. We're going to combine some terms here. 5 times 3x is 15x plus what?
21.
Which makes? Don't use your calculator.
37.
Oh, I was lost.
36x.
Okay, we just skipped this.
Thank you. And then 5 times negative 8 is negative 40. 2 times 21 is 42. So you get 42 and negative 40, which makes 2. If you left it like this, I would accept it because there are 3 factors. You could take a 2 out of this last section right here, couldn't you? So you don't have to, but that would be a form that I would accept.
Right.
You good with that?
Yeah.
Okay.
B cubed.
All right. You guys are doing very, very, very well. Okay. You really are. We want to do 3 more problems together. Okay. And then tomorrow we'll pick up with the rest. But we want to do A, C, and D. I want you to try A on your own. A on your own. Talk to the people next to you.
I'm looking at where they are.
Yeah, me.
This is negative 2. I took the negative 2 ends right here. And this one ends right there. So I know it's overlapping.
Yeah, I was just gonna say.
So why do we have
Is
to
it
make that
negative
way?
So
Like I know because it's parentheses.
I think.
Included negative 3.
just to be clear, negative 3 to 3 looks like
All the
this,
outside with the cosine and then the 4 ends would be
right?
I think these might be separate.
And then instead of drawing something like that, we can just say x cannot be 2 or negative 2.
Yeah, because of the extra
So-
to separate it. So
Oh, I forgot what.
That's the set that we want to express.
So where?
I don't know if I'm right.
So don't think of it as like the way that I wrote it.
So,
That's technically wrong.
yeah, these are not the same. You would have to write negative infinity, negative 2,
I don't know.
union,
Well,
negative 2
we
to
will
2,
still try.
union 2 to infinity. This is that. For example, this, if x can't be 2 or negative 2, that means that x could be 0. And x could be 0 because if you plugged in 0, you get 4 minus 0 is 0, or is 4. It's okay to have 4 in the denominator. But in your notation, you said that x can't be 0. Look at my notation, x can be the number 0. This is the interval notation of that, not that. So what I did is I just drew my negative 3 to 3, and then I just excluded those two.
And then, here, we did that together like last hour, but
Yep.
the division part,
So you have the exact same domain, only you must exclude the values that give you 0 in the denominator. So you have to exclude those. So in order to exclude them, I'm going to put a parenthesis.
so that is wrong, but it's sort of right.
What you're telling me here is that x cannot be the numbers 1 and negative 1, but it can be any other number. And that is inaccurate. It cannot be the number 9. 9 is not included. Okay? And so this tells me, because if you plugged in 9, you get 9 minus 81, and that's a negative value.
You really
You get a negative value, you can't exclude a negative. So I use the same exact domain, I just exclude the values of negative 1 and 1 by using parentheses.
So here's, you don't have to do negative 1 to 1.
Because it was never including the values of negative 1 to 1. It never was. See, it's not, up here we didn't include from negative 1 to 1, did we? No, because remember,
Because here is it saying negative 1 is included, and so is 1.
yes,
Okay.
because remember our original graph went like this.
So we're supposed to do all 3 of these?
No, just do that first one, I'm just about ready to help you. So, that's why we didn't include the middle, because there was no overlap at the beginning. Okay? All right, let's see what you got. What rule did you start with? Oh, you started with the box? You didn't start with the product rule? I said that's F and that's G. Is that what you did?
Yeah.
And so I got negative 6x times the cosine of 4x. We good there? And then I have a plus a negative 3x squared times the derivative cosine of 4x. Ooh, I'm going to use my little trick. What's the derivative of the inside? 4. Times what's the derivative of the outside? Negative side, so that's going to change it to a positive sine of 4x. So I have negative 6x cosine of 4x, and it's plus a 12x squared sine of 4x.
Oh wait, actually, I think I got that by like
Except I need to make sure that I write it in factored form if it is the product rule. What is the common factor you're going to take out? Negative 6x, good. I take out that negative 6x, I'm left with a cosine of 4x. It becomes a minus 2x sine of 4x. And that is my derivative.
Whoa. That's crazy.
That is crazy. Folks, this is really where you feel like you're going to be earning your college credit, okay? All right? Do you want me in the picture too? Okay, all right. No hesitation there.
Wait, post.
We good? Any question on that? Okay, let's look at letter D, and then we're going to go back to letter C. We're going to end with C, okay? C is going to give us a little bit of a run for our money.
Right, I don't know.
This one tests really how you see the order of operation, Okay? And as I set this up, I'm going to write it as -8 times the sine of 4x minus 2, that quantity to the 4th power, or is it -8 sine of 4x minus 2, all to the 4th power? Which one is it? Is it the top one or the bottom one?
Right.
It would be the bottom one.
Here's the question. In the problem, is -8 being taken to the 4th power?
No.
No, it is only the sine operation being taken to the 4th power. So it is not the bottom one, it is the top one. Does everybody see that this is a chain rule problem? Okay? What is on the outside? What's the outside structure? Good. -8u to the 4th. Excellent. So what's the inside? Sine of 4x minus 2. What's the derivative of -8u to the 4th? And then the derivative of sine of 4x minus 2, I'm going to have to use the chain rule. We'll do it nice and quick. What's the derivative of the inside? 4. What's the derivative of the outside? Cosine with the inside left alone. What do I do with those two once I produce those two derivatives? How do we come up with our final answer? We take those two and we multiply them. So I get 4 times -32 is a -128. I'll plug in u. Remember, sine goes in for u, so it's sine to the 4th of 4x minus 2. Then it's times the cosine of 4x minus 2. And that's my derivative. Agree?
Wouldn't it be to the third? Because when you did the derivative of -8u to the 4th, shouldn't it be -32u to the 3rd now?
I ate a bowl of stupid for breakfast.
Okay.
That's not kind.
Love yourself, kids.
Maybe I love myself. Wasn't so dumb. Yep, simple mistakes happen. I get it. Okay, ready for the last one? So tomorrow we just have a little bit of work to do to polish this off, okay? But let's try a number, or letter, is it letter C?
Yep.
Letter C we got there, okay? And I'm giving myself a little bit of extra room. How much room do you guys have?
You don't have a ton, do you?
Okay, well, we'll see what happens. What rules do I need to use here? The quotient rule, right? Yeah. So the quotient rule is f prime g minus g prime f all over g squared. We have a little bit of room above, so I'll use that space to find these derivatives. I'll set up my boxes so we can refer to them very, very quickly and easily. I have my 3x minus 5 to the 4th, so u to the 4th. 3x minus 5. I have 4u cubed, and I have 3. So 12 times 3x minus 5 to the 3rd power. It is really impressive how quick and efficient we can be with the chain rule, isn't it? I mean, it's fast. I have u to the 6th, I have 2 minus x, -1, 6u to the 5th. So I have -6 times 2 minus x to the 5th power. Everybody good with our two derivatives? All right. I want to find this derivative, f prime of x is equal to, what are we going to start off with? 12 times 3x minus 5, good, to the 3rd power. Then what?
2 minus x to the 6th.
2 minus x to the 6th, good. minus. So is this minus the -6? I can do plus.
Plus.
Plus my 6 times my 2 minus x to the 5th. Times 3x minus 5 to the 4th. All over what? So 2 minus x to the 12?
Right.
Yeah.
2 minus x seems to be something that comes up quite often within the numerator and denominator. We could probably take out a factor and cancel some of those, couldn't we?
Yeah.
So let's go through our factoring process here as well. What common factor do I take out of the top? Let's start with the coefficient.
6.
6 times 3x minus 5 to the 3rd times 2 minus x to the 5th. That is my common factor. As I take out the common factor, what remains here?
2 times 2x.
Then what? Plus. Yep, just the 3x minus 5. That all sits over 2 minus x to the 12th. So we are basically done here. We have f prime of x is equal to, I have 5 of the 2 minus x's here. So that's going to cross off with 5 in the bottom, leaving me with how many? Yep, 2 minus x to the 7th in the bottom now. So I'm taking care of those. I definitely have the 6 times the 3x minus 5 to the 3rd. And then let's gather some pieces here. I have 2 times 2, which is 4, and then 4 and then -5 make -1. And I have 2 times -x, which is -2x, and -2x plus 3x is x. So I get just an x minus 1 on the top. Thank you. Yes, Rosa says it looks less stupider and looks more neater. I like it. Okay, take out your homework so we can talk about where you want to attack on this one.
The attack.
Okay. All the rest of these assignments are taking derivatives. I would say that of these assignments, this one is the hardest one. Okay, I think that this is the hardest one, the grouping. And if you flip forward, okay, after your derivatives of trigonometric functions and basics of the chain rules, you're going to come to this chain rule with other rules. Now, for the first example, you just have to use the chain rule once. Okay, it's just more practice with the chain rule. But there are more pages to this. And as you look at problem 12 is similar to one that we've done in class, where you have a binomial expression to a power times another binomial expression to a power. That, you want to be able to write in that factor form, just like problem 11 and problem 10. Notice I gave you 3 of those because, if I give you 3 of them, we focus 2 of them on in class, you probably expect you're going to see that on the test, okay? So I could see where you're going to need some of that help, okay? Whereas problem number 14, you have the chain rule and the product rule together, okay? So you can handle all of this except for the very last problem involves graphing, and that's what we're going to go over tomorrow. So tomorrow we're going to get to this pretty quick. We're going to go through the square root example.
Attention students with the last name P through F, please report to the auxiliary gym for pictures. Again, students P through F to the auxiliary gym for pictures.
Yeah, so these are all.
Yeah, so tomorrow we'll finish up these notes. We'll give you some time to work. I'm guessing tomorrow you'll get about 25 minutes to work.